What we're going to do in this video is explore the very foundation of mathematical reasoning, logical arguments, and validity. While we make arguments in everyday life all the time, mathematics requires something more. It requires conclusions that follow with absolute certainty from our assumptions we call premise. We're going to think about what makes an argument valid, how we can test that validity using truth tables, and why mathematicians eventually move toward the more powerful method called formal proofs. Now, on the screen, we see a simple chain of statements. Before we define what each part means, I'd like you to take a moment to observe how the reasoning flows from one statement to the next. If you'd like, pause the video and see whether you can determine how the final statement follows from the first two. The statements are, if a person lives in Sacramento, then they are a California resident. Liam lives in Sacramento. Therefore, Liam is a California resident. We'll use this example later on. All right, let's think about this together. First, let's see what an argument means in logic. In logic, an argument is simply an assertion that a given set of statements, which we call premises or hypotheses, logically leads to another statement called the conclusion. Any argument always has two parts, premise and conclusion. A premise is a statement that provides the assumptions, evidence, or reasons in an argument, while a conclusion is the statement that those premises are intended to establish. In other words, the premises are the starting point of the reasoning, and the conclusion is what logically follows from them. An argument may have one or more premises, but it always aims to support a single conclusion. Let's see, in our previous example, if a person lives in Sacramento, then they are a California resident, is the first premise, and Liam lives in Sacramento is the second premise. And the statement after the word therefore is the conclusion, which is Liam is a California resident. Here we need to ask ourselves, how do we identify which statement is the premise and which is the conclusion? To identify the premises and the conclusion, there are two ways. First one is to look for conclusion indicator words, such as therefore, which often introduce the conclusion. If there is one, then the statement after it is the conclusion. But sometimes these words might be omitted. If no indicator words are present, we shall ask ourselves which statement is being supported. When we find that statement is the conclusion, which makes the remaining statements that provide the support are the premises. In short, the premises provide the reasons, while the conclusion is the claim those reasons are meant to justify. To understand and analyze arguments mathematically, we represent these statements as propositions and connect them using logical connectives. So the first step for evaluating an argument is to express the statements in logical forms, and this allows us to focus on the logical structure of the reasoning rather than the specific meaning of the statements. I like to think about arguments as being built from these two fundamental building blocks, propositions and logical connectives. Here's the kicker. Logic isn't actually concerned with whether your statements are true in the real world. That's because determining whether a statement is true or false often goes beyond the scope of logic and depends on the subject matter. For example, consider the statement, there are 5 million people living in Paris. Deciding whether this is true requires demographic data and statistical evidence, not logical reasoning itself. Logic is the study of reasoning, so instead of focusing on whether individual statements are true, it focuses on whether a conclusion properly follows from a given set of statements, or the validity of the argument. So, what do we mean when we say an argument is valid? We say an argument is valid if it is impossible for all the premises to be true while the conclusion is false. In simple language, whenever the premises are true, the conclusion must also be true. Then we can call the argument valid. Let's make sure we understand this properly. If you can find even one possible situation where the premises are all true but the conclusion fails, then the entire argument is considered invalid. So how do we test this? The first repeatable algorithm we have is the truth table method. What we do is construct a table for every possible combination of truth values for our propositions. We look for the rows where all the premises are true. If in those specific rows the conclusion is also true, then the argument is valid. But if we find even one row with all the premise true and the conclusion false, then we say the argument is invalid. Let's see this with our previous example. The first step will be translating each statement to logical expression. So the first statement will be P implies Q, where person lives in Sacramento is P, and a person is a California resident will be Q. Based on these assigning, the second premise will be P, and the conclusion becomes Q. Once we express each statement in logical expression, then we proceed to truth table. As we can see, only the first row is the only row where both premises are true simultaneously. Once we determine that row, we check the truth value of the conclusion. If it is true, then the argument is valid. But if it is false, then the argument will be invalid. In our example, the conclusion is true. Therefore, the argument is valid. We must remember we only need to check the row where all the premises are true simultaneously. For instance, the other rows in our example where one of the premises is false won't be considered at all in determining the validity of an argument. Let's see another example. Here we have two premises, which are if it is raining, then the ground is wet, which can be expressed as P implies Q, where P is it is raining and Q is the ground is wet. And the second premise is the ground is wet, which is Q. Then the conclusion is it is raining, which is P. Let's construct the truth table to see the validity. As we can see, both premises are true simultaneously in two rows, first and third. But on the third row, the conclusion is false. Therefore, we'll say the argument is invalid. However, as we add more variables, like P, Q, R, and S, the number of rows doubles every time. A table with 5 variables, for instance, would have 32 rows. This is where the truth table method becomes impractical. This limitation naturally leads us to the formal proof method. Instead of examining every possible case on a truth table, we establish validity through a sequence of logical deductions. In a formal proof, each step you write down must be justified either by a premise or a rule of inference. A rule of inference is a valid pattern of reasoning that allows us to derive a conclusion from one or more premises. In other words, it is a logical rule that guarantees that if the premises are true, then the conclusion obtained by applying the rule must also be true. Here are some of known rule of inference displayed on the screen. Unlike the truth table method, which checks every possible combination of truth values, the formal proof method establishes validity by deriving the conclusion from the premises through a sequence of justified logical steps. Each step in the proof is either one of the original premises or a new statement obtained by applying a valid rule of inference, such as modus ponens, modus tollens, and others. If the conclusion can be derived using only valid rules of inference, then the argument is considered valid because each step preserves logical correctness. Let's illustrate it with the previous example. First, we write the statement, then to the right we write either premise or the rule of inference we use to justify our finding. As shown here, we arrive at our conclusion using one of the rules of inference. As a result, we can say the argument is valid. Let's see another example. Here we have 3 premises, which are if I study, then I pass the exam, if I pass the exam, then I graduate, I study, and the conclusion is I graduate. Here we have 3 propositions, where we assign P for I study, Q for I pass the exam, and R for I graduate. So the premises will be P implies Q, Q implies R and P, and the conclusion will be R. Once we express them in logical expression, we can proceed to the formal proof method. The 3 propositions will be assumed to be true because they're stated as premise, so we write premise for justification. Then P implies R must be true because P implies Q and Q implies R are true. This is called hypothetical syllogism, as stated under justification. Then, finally, R must be true based on step 3 and 4. If P is true and P implies R is true, then R must be true. And this rule of inference is called modus ponens on step 3 and 4, so we write it under justification. Since R is the conclusion, then the argument will be valid. We can also check it by truth table, and we'll find it to be valid. So why do we have 2 methods? Both determine validity, but formal proofs allow us to handle complex systems that truth tables can't touch. A common mistake frequently observed is confusing truth with validity. You can have a perfectly valid argument with false premises. Logic only guarantees that if the premises were true, the conclusion must follow. Another pitfall is misapplying inference rules, like thinking that if P implies Q is true, then Q automatically proves P. Remember, that's the converse, and it isn't logically equivalent. And we're done. Hopefully that makes some sense and gives you the confidence to start verifying your own logical deductions. If this walkthrough was helpful, go ahead and hit that subscribe button to keep mastering math and logic with us here at Rimetric Walkthrough. Thanks for watching, and see ya!